All right, so translations, the real start of the whole transformations thing. And we're starting with translations, which is a slide transformation that results in a shift of the graph without changing its shape or orientation. Okay, so if it's a basic parabola, it stays a basic parabola. We're just sliding it around. Imagine that it's on the overhead or something. You can put your hand on it and move it around. Image point, the point that is the result of a transformation of a point on the original graph. So we're saying, where did the point on the original graph end up? That's the image point. Mapping, the relating of one set of points to another set of points, so that each point in the original set corresponds to exactly one point in the image set. Remember, throughout this unit, you'll be working with two types of equations. Those just general, f of x, g of x, such as y equals f of x, y equals g of x. An equation in terms of x, ones we could actually graph and do stuff with, right? That we could graph as a single function. All right. So then you had this thing to do. So for f of x, when x is replaced by x minus 2, that's kind of the language we want to use. The x here was replaced with an x minus 2. The x was being cubed. It is now the quantity x minus 2 that is being cubed. And what happened? So it's the graph, and it's translated 2 units to the right. So 2 units to the right. The point 327 lies on the graph y equals x cubed, right? You toss a 3 in there, you cube, you get 27. Its corresponding image point on the graph y equals x minus 2 cubed is 527, right? Translated 2 units to the right. So this goes from 3 to 5, and we're still at 27. Now, in mapping notation, then we say the point xy becomes the point what? X plus 2, right? So we have to add 2. So what did we do to the 3 to get a 5? We added 2. Why? Because it went 2 units to the right. So it's moved 2 units to the right. For y equals x cubed, when x is replaced with, so that, you're going to use that language a lot. X was replaced with x plus 4. The graph of y equals x plus 4 quantity cubed is the graph of y equals x cubed translated 4 to the left. The point 327 lies, its corresponding image point is negative 127. And in mapping notation, xy becomes x minus 4, because we have to move left 4. How do we do that? We subtract 4 from the x value, right? It's got to go 4 lower. And the y value is the same, 27. Should be y. Should be y, yes. Should be y. It's good. So you're awake. Comparing the graphs of y equals f of x and y minus k equals f of x. So on the same graphing calculator, and you couldn't do y minus 2 equals x cubed on the graphing calculator, right? You could do that in decimals. But so the idea is, if I'm starting with y equals x cubed, if y is replaced with y minus 2, the graph of y minus 2 equals x cubed is the graph of y equals x cubed translated 2 units. What? Up. Yeah, sorry. 2 units. I thought somebody said right. 2 units up. The point 327, its corresponding point is 329. And in mapping notation, x, y, x, and y plus 2. Okay? So we're looking at it and saying, hey, the y was replaced with the y minus 2. But the effect is that it goes up 2, and so when I'm mapping the point, I have to take the y value and move it up 2. For y equals x cubed, y is replaced with y plus 4. Blah, blah, blah is the graph translated. How many? Which way? Down. So 327 becomes 323. And in mapping notation, xy becomes y minus 4. Okay, so when you're seeing y is replaced with y plus 4, you are then thinking it's a translation down 4 units. When you're doing the mapping notation, you're thinking it's down 4, the y value must decrease by 4. Okay. Generalizations. In general, y equals f of x and x is replaced with x minus h. The graph of y equals f of x minus h is the graph of y equals x, f of x, sorry, translated h units. So, okay, I'm going to put right, but what makes it go right? If h greater than 0, right? So if h is greater than 0, it's positive. So if it's 5, we're seeing x minus 5. So if we see it following a minus sign, x minus, then we know we're going right. And it goes left if h is less than 0. So if h is less than 0, if h is negative 2, x minus h is going to be x minus negative 2, which will be x plus 2. So you'll look at it, you'll see, oh, I've got x plus. Plus means I'm going left. The point xy lies on this. Y equals f of x minus h is, so the mapping, xy goes to what? X plus h and y. Okay, so if you see x minus 5, f of x minus 5, you're going to think, oh, that's right 5. Okay, then what do? I take the x, I'm going to have to add 5 to it, right? So it's x plus h, right? Where h is the number following a negative sign. In general, y blah, blah, blah is the graph translated k units. Okay, so it's up if what? K is greater than 0. And down if k is less than 0. Point xy lies on the graph, its corresponding image point. Now, here's the other thing. When we see this, we're mostly probably going to rewrite it to be this, right? To isolate the y equals. All right. So we see y minus 2. We say y was replaced with y minus 2, which means it's going up 2. And when you see it written this way, it's going to be plus 2. So when you see the k value over here, it just does what it says it's going to do, right? It says, well, get the f of x, get the y value, and then add 2. Okay. But this becomes x and y plus k. Okay, so if k is positive, that says it's going up, right? Y minus, positive says it's going up, and then here we want to add to it. Right, and when you move it over here, when you move that k over, then it really does what you think it should do, right? I was thinking of translations being backwards, right? You've got x minus 5. Well, to me, minus, but it moves to the right. Okay, so to translate the graph y equals f of x up 5 units, replace y with y minus 5. The new equation in terms of f of x will be y minus 5. Okay, so we were looking at y equals f of x. We replaced the y with the y minus 5. More likely, we're going to write this how? Plus 5. And that does what it says, right? It says go up 5. But that says go up 5. To translate the graph, y equals root x. To the left 3 units, we blank. We do what? Replace x with. So if I want to move left, then x plus 3. And the new equation in terms of x will be, so not f of x, just in terms of x, will be y equals the root of x plus 3. Okay, so we look at it and we say, if I replace x with x plus 3, that is a translation to the left 3 units. If I want to make a translation to the left 3 units, everywhere I see an x, and that's everywhere I see an x, I will replace it with an x plus 3. So for example, if we had y equals 2x squared plus 7x plus 12, and I wanted to do this, idea of moving left 3 units, then I would have to replace the x's with x plus 3's. Okay? So you could try it, if you're saying, I don't believe that. Then you could graph y equals 2x squared plus 7x plus 12, and then you could graph that, or you could expand it out and simplify it into one expression and graph it, and you would see, okay, it really did just move it left 3, right? It didn't change the size, it didn't change the shape, it simply translated it left 3. Okay, so if I'm replacing x, it's all x's, if that's the case. Translate the graph, y equals negative 3x squared plus 2. Right 5 and down 8. We're going to blank x with, so what's the blank? We're going to replace x with, so I want to go right 5, x minus 5. I want to go down 8, so I'm going to replace y with y plus 8. And the new equation in terms of x will be, so where I see the y, I write y plus 8. Where I see the x, I write x minus 5. Okay, and then I've got the plus 2. Now, we can simplify that, right? We can write it. And generally, we do want to, right? We want to just write y equals, okay, so y equals negative 3 x minus 5 quantity squared, then what? Minus 6, right? Okay, and again, if you were to graph those two graphs on the same grid, you would see that they were the same size, same shape, just one of them had moved 5 units to the right and down 8 units. The color graphing ones are nice because you say, well, my red one is this one, and then the blue one is this one. And yeah, okay. Question? All right, so it's all about the language of x is replaced by, y is replaced by, and when we replace the y, we will often, almost always, rearrange into this form. Graph y equals the absolute value of x. Graph y equals absolute value of x minus 3 plus 1 using translations. All right, so here's the first thing we're going to do. So we're starting with absolute value of x. We end up with this, and I'm going to rewrite it like this, so that we can now say, okay, the y was replaced by y minus 1, which results in what happening? Okay, so this is up 1. The x in the original was replaced with x minus 3, which results in, okay, 3 right. So you could say up 1 or 1 up, 3 right, right 3. Doesn't matter, right? As long as you have both things. It's kind of like which way, how much, or how much, which way. So if I want to graph that, I simply need to take every point on here and move it up 1 and right 3. Now, what points we need? Well, so you obviously start at the vertex, right? That's the most identifiable point. So the vertex is now there. Got this point here, so it goes up 1, 1, 2, 3. Up 1, 1, 2, 3. 1, 2, 3, and so on. We can start to see what's happening here, right? But again, take this point, go up 1, 1, 2, 3. And this point 1, 1, 2, 3. Okay. And then you can graph. So there's your transformed graph, right? Translated graph. Okay. And to verify with your calculator, you can do it if you like. Okay. So what do? We have this transformation. We rewrite it in terms of what we've just been doing. Okay. And we'll do that for a little while, and then we'll just get to the point where you look at that and say, write 3 up 1. Okay. So you should be looking at that and just thinking, write 3 up 1, but we're always going to go back to that. Think of it as first principles, right? It gives you something to fall back on. Oh, if I write in that form, then it's going to do exactly what I know it will do. Complete following table for the given functions whose equations are expressed in terms of x. Okay, so, well, the first one's pretty easy, right? So you can do that one. Second one, so description of transformations. Let's describe the transformations in B. So what's happening? So we've got a horizontal translation left 4, so we're going left 4, and we're going up 6. So I've got the point -2, -16. If I go left 4, then we have to subtract 4, right? So we go to -6, and I go up 6, -10. And the last one, if I went from 8 to 5, then what did I do? I went left 3. If I went from -1 to -2, what did I do? I went down 1.
We want to stretch the flat value.
No, because the original one had the 2. Right? How did the original change? From the original, x was replaced with x plus 4, which results in y. A horizontal translation left 4. Y was replaced with y minus 6, which results in y. Okay? But, yeah, the 2 is in the original, and that, so remember, we have to do the translations today. Otherwise, it's too big a stretch. So, if I'm going down 1, then what do I do with the y? So y gets replaced by y plus 1. What do I do with the x? X plus 3. So what I do is, instead of the x, I write bracket x plus 3. Okay, and then I've got the -5 here. Okay, now I can write that as y plus 1 is equal to the square root of 2x plus 3 minus 6. And I can write that as, just y equals. Yeah, y equals. Or I can write that as y equals the square root of 2x plus 6, and then a minus 6 out there. So the thing is, when you see it, if I said transform form is y equals the root of 2x plus 6 minus 6, and you know you started with 2x, you got to back that 2 out. You got to take a 2, factoring it out of the x plus 6. Because what you want to be able to say to describe a transformation is to say, well, I've got this, but what was the x replaced with? So I need the x by itself in the parentheses, right? So I see, oh, okay, that's an x plus 3, left 3. You look at this, a lot of people are going to look at this and say, oh, it goes left 6, because it's plus 6. It's not. It's what modified the x value, not the 2x value. Okay? So anytime we see a transformation, and that's in there, we have to factor out the 2, right? So for a transformation, you have to see an isolated x plus or minus number. For the transformation, you have to see an isolated y plus or minus number. Okay? And the first one, that was pretty good. It's common convention to use a prime next to each letter representing an image point, right? So we say, look, here's the original function f, here is its image g, under some translation, right? So something has happened to translate or transform. We can use transform because in general that's what's going to happen. Transform f to g. So first, describe the translations applied to the graph of f in order to obtain the graph of g. Now, are they congruent? Are they the same size, same shape, same orientation? Yeah, okay. So, all we really got to look at is say, how did A get to A prime? So how did A get to A prime? Up to and right 8. Okay, so we will say you go right 8 and up 2. For transformations of vertical translation, horizontal translation, it doesn't matter what order you do them in. I generally do horizontal then vertical. Right? I'm okay if you do them the other way. Write the equation for the translated function in the form g of x equals f of x minus h plus k. All right, so we know what's happening here. The g of x is our y, right? Well, instead of g of x, you can just think of that as y, and you can say, you're going up 2, so then what do I do to g of x to make it go up 2? I subtract 2 from it. So g of x minus 2 is f of, okay, so how do we go right 8? X minus 8. Okay, and now what we want to do is we want to move the 2 over to, because we have to write it, g of x has to be isolated, right? That's what it asked for. So g of x is f of x minus 8 plus 2. Okay, so the new function g of x is the original function f of x translated 8 units to the right, 2 units up. And get used to looking at it like this. Just is and will always be what it is, right? Because it's a function, the x is always the input to the function. The up-down is an afterthought, right? Well, after you get the value, then add 2 to it to move it up, or subtract 2. So at some point, we start moving away from this and moving more straight to that. But for now, let's just keep it consistent for a little while, and then we'll loosen off a bit later. The graph of y equals f of x is shown. So we give you this, right? You can't graph that on a calculator, right? Well, actually you can, but it's 3 pieces, and it's just not worth graphing this on a calculator, right? You just need to be able to understand what the heck's going on here. Complete the following table for the given functions whose equations are expressed in terms of f of x. Okay, you can see your f of x, I can't. So what's the domain of the original function f of x? Goes from -5 to 2. And it includes both ends, right? Okay, so I'm going to use, what's that notation? Interval notation. Oh, well, I don't know. Okay. Do you want to use interval notation or do you want to use set notation?
What are we going to be using on?
You go consistent. I'm looking at the answer thing, and it used set notation. But that's okay. I mean, if you do it in interval, you can just translate.
Yeah.
So let's use interval. I don't remember why set notation exists. Like in any serious math book, I don't think they use it much. Intervals are nice. All right, so what's the range? -2 to +3? Okay. So you notice here, we've got a description of transformations column, one of which is filled in. We have an image point. We have, oh, see, here's the problem here, I guess, right? So we could just rewrite this as cross that out. All right, so I guess really I should have gone set notation here just because there was set notation already there, but now there isn't set notation there anymore. It's interval. So basically what you're doing is you look at it and you say, well, okay, here they gave me the domain and here, so I should be able to figure out what happened. So what happened to this domain to give this? Went 2 to the left, right? So left 2. And my range was this, and now it's this, so what did it do? Down 4. Right? And it's either one, right? -2 minus 4 is -6. 3 minus 4 is -1. So it's down 4. Now from that, I can write my equation in the form. Now notice it's in this form. The k value is on the left, right? It's y minus k. So what do I write to go down 4? Y plus 4 is equal to f, and I want to go left 2, x plus 2. And the image point was xy, so now it's x minus 2, y minus 4, right? Most important column on this, I think, is the description of the transformations, right? Like once you got those words, you just apply the words to the stuff. Remembering that on an image point, you're doing exactly what it says, right? You're going left 2, you are subtracting 2. You're going down 4, you are subtracting 4. Here, you're going left 3, you just write left 3. There is no up or down. You do this so that it shows a left 3. You then say, if I take the domain and move it left 3, then negative 5 goes here and 2 goes here, right? And then the same deal. Now once we do stretches and stuff, you'll see we start with a range like this. Now this range covers 5 units, right? From negative 2 to positive 3. This range covers 5 units. If we give you 2 ranges, you say, oh, ranges cover the same. But if this covered 10 units, you'd then say, oh, so there was a stretch in there, right? Okay, so we will get to that. Not this is the more straightforward stuff. But we'll get to the point where, I give you a range and I give you this range, you say, oh, you stretched it. I give you a domain, I give you, oh, you stretched it as well, right? Like, that also happened. That's not happening here. These ranges will always just be the same. Okay. Use different colors, accurately draw the graphs of each of the functions on the grid with the graph. So let's just sketch this one. I need left 2 and down 4. So here's what you do. We have 1, 2, 3, 4 points, right? So we take those 4 points and we go left 2, 1, 2, 3, yeah, make it so that it can actually fit. Go left 2, 1, 2, 3, 4. Take this point, go 1, 2, 1, 2, 3, 4. Take this point, go 1, 2, 1, 2, 3, 4. Now, nothing weird is happening here. In other words, this is going to be oriented exactly the same. But if some weird stuff was happening, which might happen later, when you do this point and this point, just join them with a straight line. Because you say, okay, I know these 2 points are joined. So that if something happened here that caused something else to happen, when you found those points, just join them. And then same thing. So I got this point. Okay, let's join it. And then we'll do this. 1, 2, 1, 2, 3, 4. That's here. And so if I had taken a transparency, put it over top of this, and sketched this out, all I would have to do is push it left 2, down 4, or it's a slide. Translation, as it says at the beginning. I don't know, do you guys do that in junior high?
Yeah.
Do you? Yeah, okay. I have no idea what happens in junior high. Like, my kid was in junior high a lot of years ago, and I had no idea back then either. So, and then you're going to do the other ones, right? So, yeah, and remember, all the answers online. The video, it only shows what's in here, right? So, but that's what Wise Time and Henry's. So Henry's it's going to start next week. It'll be Monday to Thursday at lunch and Tuesday and Thursday after school, right? We lost Dessons, and maybe the loser, but she retired and left, and so it's just not the same coverage available. Right? But anytime you want Wise Time, you want to see me before school, after school, just let me know when, and likely it'll be here, I guess, because it's kind of handy. All right. Graph y equals f of x is transformed such that. So now we're giving you a mapping, right? We're saying xy becomes x plus 4, y minus 1. So what you want to do is take that mapping and figure out the words that go with it. So what are the words that go with this? What's it doing? It's going, x is going to x plus 4, so that's right 4. And y is going to y minus 1, so that's this is where you get stuff backwards. But I'm used to doing backwards. So when I see y minus 1, that means that it should be up 1. That's in a transformation, not in a mapping. So in a map, so all you do is just think, if this was 10, then this is now 14. Right? So in a mapping, this is the point on the graph, which is now going to move somewhere else. Okay? So if that's a 10, that's a 14, figure it out for yourself. Which way is it going? Okay, I think that's right. If that's a 12, that's an 11, going down 1. The transformation, y minus k, what's that going to become? It's now going to be y plus 1 is equal to f of x. Okay? So once you have number 6 firmly in your head and understanding why everything is what it is, then you're good. Right? Because now you understand the difference between the transformation notation and the mapping notation, and how they're backwards, right? I mean, a mapping notation is what it is. There's no tricks to mapping, right? It just says take this and add 4 to it. Okay, if I do that, then I must be going to the right. But my transformation is go right 4. That's x minus 4. So these guys are going to be opposites of each other, right? But just use your words. If I give you this, you just say, that's going down 1. And how do I go down 1? I take the y value and I subtract 1 from it. If I'm at 12, I want to get to 11. How do I go from 12 to 11? Subtract 1. This goes right 4, right? You look at that. Everybody now looking at this, you should now be saying, down 1, right 4. Okay? So as soon as you say that, if I say the mapping, then you can do the mapping. All right? Here's how 30, I was up item writing for 30-2. And in 30-2, we try and be very straightforward. No tricks. In 30-1, it's the exact opposite. Right? Seriously, that's what one of the teachers said. She said, like, they just, the trickier the question and all of that. So all you need, just a lot of experience, do the homework, you'll have confidence in yourself, you will do well on the exam. And you'll go, look at that, trick me. Come on. You know, too good to be tricked. We have been taught well, and we know this stuff. Anyway, we are the top public school in the province in math, 30-1. You know, yeah, seriously.
Like grades wise or teaching?
In school versus diploma mark. In diploma mark.
Oh.
Okay, you get rid of Weber and Old Scona in Edmonton, which is a full IB school. Okay, and any other small. Okay, I'll show you the data later. Anyways, for y equals g of x, the domain is -1 to 8, and the range is 3 to 7. State the domain and range for the transform function. Okay, so the first thing is words. Describe in words what's happening. So what's this doing? I like horizontal first. So this is left 5, up 3. Okay, if I'm going to move left 5, -1 is going to go where?
2.
-1 is going to go 5 units to the left and end up at -6. Eight is going to go 5 to the left and end up at 3. Just think of a number line. There's 8, and I'm moving 5 to the left. And we get to 3. Now, you want to check this. How much distance does this cover? From -1 to +8 is how far? 9 units. From -6 to 3 is how far? 9 units. Okay, those should match. If there was a vertical stretch by factor of 2, then it should be 18 units. If there was a vertical stretch by factor of 1/2, then it should be 4.5 units, right? But it's got to match up, right? You need some internal consistency. This can't be a 4 or something. So it's wait a sec, that's 10, that's not. Okay, what's the range if I'm going up 3? Six to 10. Okay, how far does this cover? 4. How far does this cover? 4. Okay, good. Right, covering 4 units. That's what it should be doing. If we was a new domain range R respectively. Okay, so this is the B part of this question. It refers back to these numbers, right? Like don't look at that and go, wait, what? I don't. Okay. So this one was, here's the transformation, what are the new domain and range? This one is, here's a new domain and range, what transformation occurred, right? So this has to cover 9 units and this has to cover 4, and it does, and you can do that. The domain and range of y equals h of x minus 2 minus 4 are, x is less than or equal to 5 and y is greater than or equal to -6 respectively. State the domain and range of y equals h of x. So what's the very first thing we do? Okay. Well, so what we could do is this. So we might want to start by just saying, all right, let's rewrite this. Question are we on? 8. Okay, so we might want to put it into this form. Y plus 4 is equal to h of x minus 2. We can list that. So let's say we do y plus 4 is equal to h of x minus 2. Then we've got the original function, y equals h of x. And then we're going to list the domain and the range. And the domain and range of this, so it's the set of all x such that x is less than or equal to 5. And it's the set of all y such that y is greater than or equal to negative 6. And so, what does this do? Down 4. What does this do? Right 2. So, this says, I started with some original range which was moved down 4 and became this. Right? Like this is the range after we moved down 4, so where did we start? Okay, so we started somewhere, we moved down 4, we ended up with greater than or equal to negative 6. Where did we start? Negative 2. And we started somewhere, we moved right 2, and here's where we got to. So where were we starting if after moving right 2 we ended up here? 3. Okay, so you get that? The main range we were given were the after the transformation. So we got to say, well, these are the transformations that happened, and this is where I ended up after that transformation. After I went down 4, this is where I am. So I must have started up 4, right? Like the original started 4 higher than that. The original started, I moved right 2, so the original was 2 to the left of there. All right, tricky, huh? So this is Math 30-1, right? So a lot of times the earlier questions we gave you this. Here's the domain. What happened to it? Oh, this transformation happened, so it did this. Here's the new domain. Where did it start out? Oh, then I got to back the transformation up, right? This was right 2 means that I have to go left 2 to get to there, and I have to go up 4 to get to there. And then, once you've got that, just look at this and start here and then just apply the transformations. If I go right 2, I'm going to end up at 5. If I go down 4, I'm going to end up at negative 6. Right? And that's your way to check that, right, is to say, fine, let's do it the right way around. What if I started here and then this happened? Yeah, that's what I would do.
On the test, are you going to ask them, or are you going to tell us the right answer?
Well, okay, if it's this, then you're writing it in set notation. Okay, so you must be consistent with, which I failed to do in that other one, but because it was off the page and I wasn't looking that far down, and so we crossed it off occasionally. But yeah, stay consistent with it, just to get you practice in both forms, so that on the diploma you're looking at it's just like, yeah, okay, whatever, it's a set. It's in there. Is this the next one? Given the equation and graph of a function, the thin line, and the graph of the translated function, the thick line, write the equation of the translated function in terms of x. So in terms of x means all of these originals can be graphed, right? You plug them into your calculator. You can graph y equals x minus 1 quantity squared minus 3. We all know what that looks like from last year. It's a parabola that opens up. It's the congruent to y equals x squared, and its vertex is at 1, negative 3. Right? So easy to draw, right? Go over 1, up 1, 2, 4, 3, 9. You can do a very nice, accurate sketch. Now, something has happened. Now, this maintains the same shape. It's congruent to this, but it's been moved. And what magic point are we going to look for? Yeah, right? So all I got to do is say, all right, what happened? 1, 2, 3, 3 left. 1, 2, 3, 4, 4 up. So left 3, up 4. So I want to emphasize, use the words, right? Get the description, write it down. This is what's happening in words. Once you have the words, everything else from that point is pretty easy, right? If I see 3 left, then I say, okay, well, what did we start with? Y equals x minus 1 quantity squared minus 3. So y equals, actually, whoops. Actually, let's do this. So it's y plus 3 equals x minus 1 squared. So that's the original, right? Slightly rearranged, just to be y plus 3. Okay, if I'm going up 4, what do I do? You replace the y with y minus 4, right? So to go up 4, how do we go up 4? You see y, you replace it with y minus 4. Here's how you do it. You make sure it's in parentheses, right? Y minus 4, okay? Now the plus 3 is still there, right? Because we're just replacing the y. What have I done? I have now moved it up 4 by replacing y with y minus 4. Equals, what am I going to do with the x? I'm going to replace it with x plus 3. So you see that x? And I'm going to do that. What do I do with that minus 1? It's still there. It's supposed to still be there. Okay? So that's what happened, right? I've rewritten it slightly to just move the 4 over. You don't have to necessarily, but stay consistent. And then we just stay very consistent, right? If I replace x with x plus 3, it becomes x plus 3, yeah, it becomes a horizontal translation left 3 units. What about the 1 and the squared and all? It doesn't matter. You see an x, replace it with x plus 3. Okay, you see a y, replace it with y minus 4. Okay, now clean it up. So this becomes y minus 1 is x plus 2 squared, or y equals x plus 2 squared plus 1. Now, if I told you y equals x plus 2 squared plus 1, and this were last year in 20, then you would say parabola opens up, congruent to y equals x squared. Vertex is where? Negative 2, 1. Right? Where's the vertex? Negative 2, 1. Aha, you got a check, right? Built-in check there. Okay? So I ignored I only use this just to count and count, right? I'm just counting that, right? I mean, we all could have written this equation based on, 20-1. Like, forget the whole transformation stuff. But, look, we did the whole transformation stuff, and hey, it gave us the right answer, right? And how do we verify? We look at that and we say, oh, yeah, that's where the vertex is. Okay. So when you try these two guys, you're going to do the same deal, right? It's like I go right 2, down 1. Right 2, down 1. Now what do? Okay, I do the whole replacement thing. Okay, and then I clean it up. This moved, well, actually I think it just moved up 3. It moved up 3. Okay, what do? I replace y with whatever, y minus 3, and then rewrite it. Okay, and then I can graph both of them and say, yeah, hey, that's right, it works. Okay, so you can verify graphically. You have to know how to use the graphing calculator. Obviously, that's what you have with you on January 25th. But if you want to sit and do this at home and you've got like decimal, it's way nicer, right? Like it's, and then you can graph them as well. Okay, so it's just a way. Is that it? Wow. Okay, so one other thing, but